Next, we're going to study about priority encoder. This is a more advanced version and more efficient version of a typical encoder. Now, in priority encoder, what happens is, in normal encoder, what happens is your only one input is active at a single time, and depending on that, your respective output is defined. Now, your circuit, what does your circuit is, it goes on checking all the inputs, and depending on whatever input is active, it gives the according output. But in priority encoder, what happens is, it doesn't check all the inputs. It only checks the input with highest priority, or you can say a highest subscript or higher subscript. This n would be a subscript that is given here, d0, d1, d2 and d3. Now D3 is given as the highest priority. Whenever D3 is high, we don't go for checking the lowest priority inputs. Okay, and that's exactly the concept of priority encoder. You see here, if D3 is 1, we don't check D2, D1 and D0 because those are of lower priority or lower subscript value, and we mark this as the don't care conditions. Okay, the same also happens here. If you are going to consider this iteration, we go on checking D0, that is low, D2, that is low, D1, you see that is high, so we don't check or we don't go for D0 checking. Okay, so that's what is your priority encoder. So these are your inputs, that is 4 inputs, and your particular output. We're going to consider these are 2 outputs. Okay, so according to 4 input, you're going to have 16 possible combinations. So you're going to use the 4 by 4 matrix, and thereby you will find the solution to x and y. I've also introduced another variable here, another iteration here. If all the inputs are 0, then the output is, we don't care about the output, and there is a valid bit also, that would be 0. That is a special iteration, and we have defined it here. By using K-map, we will find the solution to be x would be d2 plus of d3, whereas y would be d3 plus of d1 plus of d2 complement. Okay, so you will find this expression from the K-map. And if you go for valid bit, you'll see it would be the OR operation. Naturally, it would be the OR operation of all the inputs. Okay, so this defines that valid bit defines that only at least one input is active at a single time. If all the inputs are deactivated, we can say that the encoder is deactivated. Okay, so this is your priority encoder. Next, we are going to study about multiplexer and demultiplexer. We will begin with multiplexer. Now, multiplexer is a combinational circuit that has 2 to the power n input, whereas only one output. This is different from the encoder and decoder concept because it has only one output or one input depending on what you are considering. Now, it has 2 to the power n input and one output, whereas it also has a third input that is known as a select line. Okay. Now, depending on the value of the select line, particular input is directed to the output. Okay, so if you're going to consider a simple example of a 4 by 1 multiplexer, this is an example of a 4 by 1 multiplexer. Let me just draw it on a package basis. Four by 1 mux. We write it in short form as mux. Let the select line be S1 and S0. Let the 4 inputs be I0, I1, I2 and I3. Let the output be Y. Okay, so what happens is depending on the selection line, that is we have also tabulated here, depending on the selection line, particular input is directed to the output. Whenever the selection line is 00 or S1 and S0 is 00, your input I1 would be directed to the output Y, or Y would be equal to I0. Whatever the input I0 would be reflected on the output. If 0 1 is activated, of the select line combination is 0 1, then I1 would be directed to output. Okay, so output will follow I1. If the respective inputs, other inputs changes like I0, I2 and I3 changes, that will not affect the output. Okay, only I1, the changes in the I1 will be reflected on the output because your select line selects that particular input. Okay, so we can have multiple inputs which may change simultaneously, but depending on the select line, your output would follow a particular input. So this would be your combinational circuit for the 4x1 multiplexer. Okay, it has output altogether from the respective AND gates. Now depending on the select line, only one input would be directed to the output. Okay, so this is your select line. You can deduce that how this particular circuit works. This is very simple to know. As you know, the AND gate, if you see the operation of this first gate, if you're going to consider this, the first gate, you see the input to that is S1 complement, and the second one would be S0 complement. Okay, so when the first iteration comes, both are 0, so this is going to be 1, this is going to be 1. Now the other inputs, if you consider whatever is going to be the input for this, S1 complement here, S0 complement here, sorry, not complement, simple. Okay, so you can say 1 is 0, 1 is 1 here, one input is 1 here. Next one, if you consider this one, you see this one is S1, this one would be S0 complement, and the last one would be S0 and S1. Okay, so this one would be 0 0, this one would be 1 0. So if you consider all these configurations, you will see, or at least one of the input to all these AND gates is going to be 0, so output would always be 0. Whereas in this first gate, you'll see all the inputs are going to, all the other inputs except the input 1 is 1 0, I0 is going to be 1. So what happens is the output will follow the I0. If I0 is 0, the output is going to be 0. If I0 is 1, then the output is going to be 1. So the output will follow I0. So this would be I0, and the output would be I0 plus 000. Or you can say that output will follow I0. And this is how this multiplexer works. Okay, you can deduce how this particular circuit works in this particular format. Now if you go for the reverse of that, we have a demultiplexer. It has one input and 2 to the power n output. Okay, now depending on the select line, the particular output will follow the input, just the reverse of this multiplexer, and we call it demultiplexer or demux in short. Now the construction for that is like this. Whenever S0 S1 is 00, we will find that your input would be available at the output Y0, whereas all others will not follow the input. Okay, those are going to be 0 or low, logically 0 if you say. So this is how a demultiplexer works. This is just the reverse of that. Okay.